Good morning, everybody. I'd say you're definitely allergic to this voice at this stage because I certainly am. And it's like Groundhog Day. Good morning, everybody, and welcome to today's class lesson. And I'm full of enthusiasm, guys, aren't we? But it would just be so much more different in the classroom. There's Em again, and I really miss it. But we have to make do with this kind of learning, and it's really difficult, guys. I completely understand it is, and I hope that in some way I'm helping you, my little chicks, all of you, and Miss Campbell's little chicks, because you are little chicks, to just have a better understanding of what's going on from Em. Yes, from me, Em, Miss Walker, and from Miss Campbell. So I want to refer back to yesterday, and I'm going to hone in on this sum. And we can see we have 6 tenths, 100 over 200, 12 over 20, 15 over 50, 32 over 40, and 21 over 30, and 24 over 120. And what I did, guys, I broke it down to their simplest form because it's easy to work with fractions if you have if they're expressed in their simplest form. And so they're all highlighted there, except obviously Mary always makes a mistake. We're not perfect teachers, anything but perfect. So I should have highlighted the fifth there, guys. I've only seen it now. So what I did was I got the equivalent fractions in their simplest forms for each of the fractions that was stated. Then I put them in order from greatest to smallest. So the 1/10, a half, 3/5, 3/10, 4/5, and 7/10, and a fifth. And I decided that I would use 10 as the common denominator and see how many fifths are equal to 1/10, how many, and so forth. And I found out that 4/5 was the same as 32 over 40, 7/10 was the same as 21 over 30, 3/5 was the same as 12 over 20, half was the same as 100 over 200, 3/10 was 15 over 50, and 1/10 is 6 over 10. And using those, the fifths and the tenths, I was able to establish what was the largest fraction right all the way down to the smallest. And I think all of you would have known straight away that the tenth was the smallest because a tenth is smaller than a fifth anyway, and it was just 1/10. It wasn't 7/10 or 8/10, which is 2/5 anyway. So then when I got that answer, I brought them back to their original form because you must bring them back to what you were asked. And I found out that 32 over 40 was the largest, then 21 over 30, then all the way down to 6 over 10, which is equivalent to 6 over 60, which is equivalent to 1 over 10. You might notice, guys, that in certain places in the classes before, I might say something incorrectly, and I don't want to, like, I sometimes have to do so many takes because you know the way I go on, and I just have to roll with it. This doesn't come naturally to me talking to a screen. I know you're thinking, Miss Walker would talk to anything, even herself. Yes, the best conversations I've had, certainly with myself, and the worst. So guys, we're going to go to topic 27 again, data 2, but we're doing page 169 today. And this is all about constructing pie charts. So this pie chart shows the mobile phones used by children in Parkway Youth Club, and the Microphone, Nokia, Sony Ericsson, Motorola, and Samsung. And then the children, there were 8 using Nokia, 4 for Sony, 6 for Motorola, and 6 for Samsung. So we have to find out what fraction of children use a particular phone. I've told you before, to express numbers as a fraction, you put the number over the total number. So 8 for Nokia goes over the total of 8 plus 4 plus 6 plus 6 children, which is a total of 24 children in the class. And they all have their individual preferences, either for Nokia, Sony, Motorola, or Samsung. And then you put the 8 over the 24 for Nokia, the 4 over the 24 for Sony, the 6 and the 6 over the 24 for Motorola and Samsung. And then you express them in their simplest form. And 8 over 24, well, 8 goes, what you do to the top, you do to the bottom. What you do to the bottom, you do to the top. What you do to the numerator, you do to the denominator. What you do to the denominator, you do to the numerator. And I'm saying that so quickly because we've been saying it, Miss Campbell and I have been saying it over and over and over again. So 8 and 8 goes once, 8 and 24 goes 3 times. Therefore, 8 over 24 is equivalent to a third. A third is in its simplest form. Why is it simplest form? Because you cannot break it down any further. 4 over 24 is 4 to 4 goes once, 4 and 24 goes 6 times, so it's 1 over 6 in simplest form. Why? Because we cannot break it down any further. Then we have 6 over 24, 6 over 24, 6 into 6 goes once, 6 into 24 goes 4 times, and that is 1 over 4, and it's in the simplest form. And then Samsung just is exactly the same. We need to calculate what fraction of the full circle is always 360 degrees, half circle is 180 degrees, a quarter of a circle is 90 degrees, a third of a circle is 120 degrees, and you must really know those off by heart, guys. So you use the total 360 to establish the number of degrees equivalent, which expresses a third or a sixth or a quarter. So a third of 360 is 120 degrees, we know that, and a sixth is 360. If we know our 6 times tables, we know 6 sixes are 36, so 60 degrees, and then 4 nines are 36, which is 90 degrees. And so we have established that Nokia, Sony, Motorola, and Samsung have these degrees equivalent to their fractions, are expressed in as they're expressed from getting the fraction of the total number of degrees, 360. So if you put 120 over 360, express the Nokia over 360 degrees, the total, you would break it down into its simplest form, a third. Same for 60 over 360, you break down into a sixth. 90 and 90 over 360 expressed as a fraction would be a quarter, and then you check back over it so you know you're completely right. And if you add 120, 60, 90 and 90, they should add up to a total of 360 degrees for the full pie chart, for the full circle, for the full 360 degrees. And then we go, and now we're going down to fill in the table sketch of the pie chart. So we have type books, fiction, cookery, non-fiction, autobiography, biography and comics, and with the number of children, fraction of the total, and the angles. So I suppose what you have to do basically, guys, here is just fill in the missing parts using the information you're given. Okay, so we know that there's 10, 25, 5 and 5. So we know, like, you just have to use the information, guys. Now, you see there, I would, anything with 2 pieces of information, like the number of children that expressed an interest, their favourite book was non-fiction. And then you have the angle for that, okay? So we know that 25 is 90 degrees, and 90 degrees is a quarter of 360 degrees. Sorry, it's shaking all over the place. Apologies, guys. And if 90 is a quarter, that means 25 is a quarter of the children. Do you understand that? And you're all shouting, of course we do, Miss Walker. Great. So if there's 25 is a quarter, then the total number would be 100. Now, do you understand that, guys? You see, if 25 is a quarter of the children, and the degree in 90, we know that because 90 degrees is a quarter of 360, because 90 by 4 is 360. Therefore, to get 25 children is a quarter of your total number of children. So if that's 1 quarter, you multiply by 4 to get 4 quarters, and so forth. And then you see, always go to always look at the boxes that give you the most information. For example, non-fiction, autobiography also has 2 pieces of information. It is the number of the children, and it also has the fraction. So 1/20 is equal to 5, and you just work out the angle then. So according to what you call it, the fraction. But then we have the angle, we have an 18-degree angle there, guys. So to get the fraction for that, to express that 18 degrees as a fraction, we must put it over the total number of degrees. So 18 degrees over 360. Always use the information that you've been taught, that you've heard in class, that you've heard in this lesson. Remember at the very beginning I said to express a number, as a fraction, you must put the number over the total number. It's the same here. It's just degrees. It's not children this time. It's degrees. So it's 18 degrees. We have to put it over degrees. You put the children over children. Do you understand that, guys? So it's 18 degrees over 360, and you work out that fraction. Then you have your fraction, and then you'll be able to get a total number. You'll be able to get the children, because we know that the total number of children is 100, and we only found that out by looking at the information that's provided, where we have more information. You always are best starting with, even with the magic squares. Always look to the line or the row or the diagonal that has the most information on it, in order to complete your magic square, or in order to complete your information in this table. And then you have to sketch the pie chart, guys. So you need your compass and you need your protractor to measure the degrees, as we did in class before. And remember, you always start at 0. Do not start at 180. 180, of course, is a straight angle. It's half your circle. But please, when you're measuring, start at the 0. Start at the 0 always. And look at the pie chart of teachers' cars. Some cars. Answer the questions. We have the Toyota. We have, yes, I wonder who has one of those. And we have the Ford and the Nissan and the Hyundai. It's so true. They are the teachers' cars in general. And 6 teachers drive Ford cars. How many teachers drive Toyota? So you use the information, use the degrees. We know 120 degrees is a third. And you could just remember your common denominator and so forth. I'm not going to spoon feed you here, guys, but obviously you know the answers will be uploaded tomorrow. And so 6 teachers. What fraction of teachers drive a Nissan? What number of teachers were surveyed altogether? How many degrees are in each of these sectors, okay? So remember, you're looking saying, geez, how am I going to find out how many teachers there are? It said 6 teachers drive Ford cars. Look at the information, guys. Examine it carefully. Remember what I said. Every piece of information in maths is relevant. A lot of what I say in class outside maths can be, no, not a lot, please. Some things I say, you know, just, they're not as important as I said. Everything that comes out of my mouth in maths is extremely important. Do you remember that, Miss Campbell? Do you know that, Miss Walker's class? Miss Campbell's class, Miss Walker's class. No, I've been saying that forever and ever. And you cannot miss 1 second in maths class, because you will have missed something important pertaining to the concepts that we're covering. And so what I'm saying, guys, is look at all the information. Look at the how it interacts, the information interacts with each other, how it relates to how the information relates to each other. That's the thing about maths. It's precise, it's condensed. There's not reams to learn, there's not reams to read over, but it all is there for a reason. It's not thrown in just as I said, as a decoy. It's there for you to work with, and you just have to look at what you have and see how that impacts or relates to other pieces of information in order to come to solve your problem. Okay, guys? Now, for dessert, we're having revision sheet. Hold on. Yeah, this is number 1. So you're going to do these guys today. Just remember. I'll have these uploaded tomorrow, first of all, and the answers, and they will be very explicitly presented. I actually have done them already, and so there will be, you know, you'll be able to follow it step by step. And you know, you remember what I said. Always add the whole numbers first, and I do that because it makes sure you take care of the whole numbers so you don't forget about them. So you add your 5 and your 2, and then you find your common denominator. Remember, you have to find a common denominator before you can continue. And also, guys, if when you're doing the takeaway, like for example there, 5 at the end, 5C or 3C, 5 and a tenth take away 4 and 3/5. 5 take away 4 is 1. 1/10 take away 3/5. Now, if the tenth, when you convert the fifths into tenths, and tenth take away 3/5 is going to be 6/10. So you will have to go to your 5 and knock off 1. You're left with 4. Bring over a whole, but you'll have to change that whole into what? That whole unit. It becomes 10/10, and 10/10 and 1/10 become 11/10, and then you proceed. And it's going to be the same, only the same if the number you're taking away from is smaller. So 5 and 5/8 plus 2 and 3/4, 6 and 5/12 plus 5 and 5/6, 8 and 2/3 plus 5 and, sweet Lord, guys, 7/9. Unbelievable. 5 and 5/12 take away 5 and a quarter. 7 and 5/9 take away 2 and a third. 8 and 5/6 take away 2 and 2/3. 6 and 2/9 take away 3 and 2/3. 2 and 2/8. Is that 2? I think so. Yeah, 2/8. Guys, my writing. Take away 1 and 3/4, and 5 and a tenth take away 4 and 3/5. And like, guys, I was doing those before school, so sometimes I'm trying to get lots of things done. So, hence the horrific writing there. Anyway, so
guys, I'll have that uploaded for you tomorrow, and also the other answers from page 169 uploaded, and they're good. They're easy. They're easy to do once on page 169. Once you start putting the information, thinking about the information, thinking about what you've been given, and then seeing its relationship with the relationship it has with other numbers and things you've been asked to do. Okay, guys, we'll talk to you tomorrow. Oh my gosh, that was a long one today. God love you listening to this. Anyway, slán go fóill.